In this numerical, let us find the current in all the branches of the network shown in figure. So, there are 6 resistors whose values are marked. We have to find the current flowing through these 6 resistors. So, the first step is to mark all the nodes. As we can see here, there are 3 branches. One branch has 80 amperes incoming towards this node, and the other 2 branches have resistances of 0.02 ohm each. Similarly, we have 5 more such nodes. So let us mark all these nodes as A, B, C, D, E, and F. The next step is to mark the unknown currents. So let us assume the direction of unknown currents in these branches. Let us assume that the current is flowing from A to B, B to C, C to D, D to E, E to F, and F to A. That is, let us assume that the current is flowing in clockwise direction in this loop. So the second step is to mark all the unknown currents using KCL. So once we have marked this direction, we have to name these unknown currents. So if we give 6 different names, it's difficult to solve this numerical. So what we shall do is from A to B, let us assume that the current flowing is termed I. So now let us apply KCL at this node B. So I is incoming current, 60 ampere is outgoing current, and the current flowing from B to C is unknown. So applying KCL, we will get the current flowing from B to C as I minus 60 because we have assumed it to be flowing from B to C, hence it becomes outgoing current. So incoming current is I, 2 outgoing currents, and if we apply KCL, we get I minus 60. Similarly, at node C now, if we apply KCL, I minus 60 is incoming current. Another 60 amperes is also incoming current. So I minus 60 plus 60 will give us I as the current flowing from C to D. If we apply KCL at this node D, I is the incoming current, 120 amperes is the outgoing current. Current from D to E is outgoing current here. So I minus 120. Current I minus 120 is incoming current to node E. 70 amperes is also incoming current to node E. The outgoing current, which is flowing from node E to node F, will be I minus 120 plus 70, which is I minus 50 amperes. Current flowing from F to A can be found using KCL at node F. I minus 50 amperes is incoming current and 30 amperes is outgoing. Similarly, current from F to A is outgoing current at this node F. So I minus 50 minus 30 amperes will give us I minus 80 amperes. So what we have done, we have written all the 6 unknown currents in terms of I. So this is where we apply the KCL or Kirchhoff's current law. The next step is to apply KVL. So we have a loop here which is formed starting from node A, B, C, D, E, F, A. So we shall apply KVL to this loop and find the value of I. As Kirchhoff's voltage law states, the algebraic sum of potential drops across a closed loop is zero. So if we move from A to B in the direction of current minus 0.02 times I, B to C minus I minus 60 into 0.01, C to D minus I into 0.03, D to E minus of I minus 120 into 0.01, E to F minus of I minus 50 into 0.01, F to A minus of I minus 1, I minus 80 into 0.02 ohms. So equals 0. So we have applied KVL to the loop, equated to 0, and upon rearranging, we are keeping the terms having I on the left hand side and the constant terms are put on the right hand side of the equation. Solving for I, we get I equal to 39 amperes, which means that the current I flowing from A to B is 39 amperes. So we have found current from A to B. We have to find current in all the branches. So substituting 39 in all these uh, current expressions, we will find what is the current in all the branches. So the last step is to find all the branch currents. So substituting for I, we get the answer. As you can see here, current flowing in branch BC, it is I minus 60. 39 minus 60 will be minus 21. What does this negative sign indicate? Negative sign indicates that the current is flowing in the opposite direction. So we have assumed current is flowing from B to C, but in reality, current is flowing from C to B with a magnitude of 21 amperes. Thank you.